The AI industry is collectively making one of the most expensive mistakes in technological history right now. Trillions of dollars in investment and countless engineering hours are being funneled into developing ever larger models with hundreds of billions and even trillions of parameters. Everywhere you look, from research papers to boardroom presentations, the conversation revolves around scaling laws, new architectures, and chasing incremental gains on standardized benchmarks. Yet, in private conversations with those building at the frontier, a different story emerges. The harsh reality is that most AI projects, despite all this investment, are struggling to deliver consistent, reliable value in real-world conditions. The root cause is something many have suspected but few have fully addressed until now. For years, the dominant approach has been model-centric. Data was treated as raw material, something to be gathered, given a quick, clean, and then fed into the sophisticated model everyone hoped would magically produce intelligence. This mindset has finally hit its ceiling, leaving behind stalled deployments, unexpected failures, and massive opportunity costs. This is where data-centric AI comes in, as the most important paradigm shift happening in artificial intelligence today. It represents a fundamental inversion of priorities. Rather than pouring all energy into constantly iterating on model architecture, hyperparameters, and training procedures while treating data as a static input, the leading teams are now keeping the model relatively fixed and directing the majority of their intelligence toward engineering exceptional data foundations. At its core, data-centric AI is about recognizing that the quality, structure, diversity, and richness of your data is often the biggest lever for performance improvement. Small, thoughtful changes to your dataset can deliver bigger gains than switching to a larger model or a more complex neural network. This shift moves the focus from model hacking to data engineering at the highest level, unlocking capabilities that were previously out of reach, even for the most advanced systems. Let's explore this in greater depth with some high-level educational insight. In the traditional model-centric world, problems like hallucinations, bias amplification, poor generalization to new scenarios, and unexpected failures are common. Why? Because models are masterful pattern matchers at heart. They absorb and often magnify every imperfection in the training data: noisy labels, imbalanced classes, missing context, and hidden biases. The result is brittle systems that work beautifully in the lab but disappoint when deployed into messy, unpredictable environments where distribution shifts occur naturally. Data-centric thinking changes the game entirely by treating data as the primary variable to optimize. Teams now invest heavily in systematic data curation, active learning strategies that intelligently select the most informative examples, and continuous quality improvement cycles that evolve the dataset alongside the model. They implement rigorous validation processes, use automated tools to detect anomalies and inconsistencies at scale, and collaborate closely with domain experts to refine labels and add meaningful context to every example. This creates a foundation where even modest models can outperform far more complex ones trained on lower quality information. A standout technique in this new paradigm is the strategic use of synthetic data. When real-world data is scarce, expensive, or protected by strict privacy regulations, advanced generative methods allow teams to create high-fidelity synthetic examples. These generated samples are designed to match the statistical distributions and edge cases of real data, while being perfectly labeled and balanced. Using techniques drawn from generative modeling, teams can simulate rare events, balance underrepresented categories, and expand coverage without compromising confidentiality. This approach not only accelerates development cycles dramatically, but also helps fill critical gaps that real data alone cannot cover, leading to models that generalize better and hallucinate less in production. Beyond volume and variety, the emphasis is on creating self-improving data flywheels, one of the most valuable insights in modern AI development. The process is elegant in its logic. Deploy your model in controlled settings, analyze exactly where it underperforms or lacks confidence through detailed error diagnostics, then strategically generate or collect new data targeted precisely at those weaknesses. Human experts and automated systems work in tandem to clean, enrich, and validate this new information. Over time, this creates a virtuous cycle where better data produces stronger models, which in turn help identify even more valuable data improvements. The flywheel compounds advantages, turning data from a one-time cost into a self-reinforcing strategic asset that keeps delivering returns long after initial training. Another essential element is comprehensive data provenance and lineage tracking. In serious data-centric organizations, every piece of data carries rich metadata, its origin, all transformations it has undergone, who reviewed it, what regulatory framework it falls under, and its assessed quality score. This level of traceability is no longer a nice-to-have. It is becoming table stakes for building trustworthy, auditable, and governable AI systems, especially as regulations tighten and deployments scale into high-stakes domains like finance, healthcare, and autonomous operations. It gives teams the power to trace exactly why a model behaves a certain way and to make targeted fixes without starting from scratch. The outcomes from making this transition are substantial and measurable. Organizations embracing data-centric principles are reporting significantly higher success rates for their AI initiatives, faster paths to production, superior generalization across environments, reduced bias, and lower long-term maintenance costs. Most importantly, they are building something extremely difficult to replicate: a deep, proprietary data advantage that serves as a true competitive moat. As powerful foundation models become more commoditized and accessible to everyone through open platforms, the unique quality, domain specificity, and engineering depth of your data becomes the differentiator that matters most in the long run. This shift is especially critical as we move toward agentic AI systems, intelligent agents capable of planning, reasoning step by step, using external tools, and executing complex, multi-stage workflows autonomously. These agents cannot function reliably or safely on top of poorly understood or low-quality data. They require rich semantic context, consistent quality across modalities, and well-documented provenance to make sound decisions in dynamic, uncertain environments where a single flawed input could cascade into major errors. Implementing data-centric AI is not just a technical exercise. It requires a genuine cultural and organizational evolution. Data teams evolve from being viewed as support functions to becoming core strategic partners in AI development and decision-making. It demands closer collaboration between machine learning engineers who build the models, data specialists who engineer the foundations, and business domain experts who understand the real-world nuances. It also calls for investment in modern data infrastructure that supports dataset versioning, real-time quality monitoring, automated cleaning pipelines, and seamless feedback loops between models and data infrastructure that turns what used to be painful manual work into scalable, repeatable excellence. For individual professionals and leaders watching this video, the implications are clear and urgent. The skill set of the future data scientist and AI engineer is shifting in a powerful way. Technical mastery of models remains important, but the ability to deeply understand, curate, engineer, and govern high-quality data is becoming the true differentiator that separates good careers from legendary ones. The most valuable question is no longer solely, how do I optimize this model? But increasingly, how do I make my data more informative, cleaner, more representative of reality, and more aligned with the problems we're actually solving? In 2026, and the years ahead, the most successful AI organizations won't be remembered simply for having the largest models or the flashiest demos. They will be the ones that quietly mastered the art and science of data-centric development, building intelligent systems on top of rock-solid, meticulously engineered data foundations that deliver sustained value year after year. The data revolution in AI is no longer coming. It is here, unfolding right now in the most forward-thinking teams around the world. The only remaining question is whether you and your organization will actively participate in leading this shift, or risk being left behind by those who do. If this message struck a chord with you and sparked some new insights about where the real power in AI lies, hit that like button, subscribe for more in-depth, high-level insights into the future of AI and data, and let me know in the comments. Are you and your team currently working in a model-centric way, or have you started making the transition to data-centric AI? I read every comment, and I'm excited to see where everyone stands in this critical evolution. Thank you for watching. In upcoming videos, we'll explore practical frameworks, tools, and real-world techniques you can start applying immediately to begin your own data-centric journey. Stay curious, stay ahead, and I'll see you in the next one.